Guys, this is the second section or the second part of section 9.3. It's page 265 of the student journal. Possible triangles in the SSA case. So I wanted to make this separate because it's includes drawing, which I know some of you. I mean, it's a good strategy. It's been a good strategy, but maybe some of you aren't used to it, or you just need practice or whatever. So I wanted to make this video separate to model some of the drawing strategies and to go over all these cases because uh, obviously there are six, as in 1, 2, 3, 4, 5, 6. So first off, it says possible triangles in the SSA case. So maybe some of you guys don't even know what SSA means. And in the context of triangles, S stands for sides and A stands for angles. So a side, and an angle. And we're trying to determine how much information they give you, right? Because every triangle has, three sides, 1, 2, 3, and then three angles. One angle, two angles, a third angle. Or angle, 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 side, side, side. And in any of these problems, they'll give you three bits of information. And they're going to be sides or angles, but you don't know which pieces they're going to give you. They could give you angle, 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 side, 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 um, and then everything in between. So you have angle, side, angle, 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 side, whatever, in any order. But we need to know how to draw it, and we need to know what it means. So as I said, SSA stands for side, side, angle, which means that they're giving you a side, and an angle, a side, an angle, a side, an angle, a side, an angle, side, angle, side, an angle. One thing I kind of want to point out is it seems like all of these are going counterclockwise. Is that the one? Yeah, counterclockwise. Um, and that's like just because it's examples, but that's not the only way you could do it. And also, I wanted to show you some things that are not SSA so that you guys have a better differentiation. So here are some drawings I made. So this is a side, an angle. I do not know this angle because if I did know that angle, it would be SAS. What else? We got a side, an angle. We have a side, an angle. We have a side, and the angle that is given to us in the problem. And what that looks like is, if you draw it out, and I'll do some examples, like I'll do like uh, 13 later to show you like what it's even referring to. Um, but so everything on the left are examples of side, angle. Everything on the right is not. This is side, angle, side. So this does not apply to a side, angle, side. And then we have a angle, side, angle. So again, this does not apply. And then lastly, we have an angle, and a side. So again, I just want to clarify what we are referring to, and this is a SSA. This is SSA. And in these pictures, um, it's not that they don't apply to the problems at all because it says state the case AAS, ASA, SSA, so that they exist. But it's basically like, these only apply to SSA. And then actually, if you go up here, where does it say? Two angles in one side, AAS, or ASA, determine exactly one triangle, but two sides and an angle opposite one of the sides, SSA, may determine no triangle, one triangle, or two triangles. So what does that look like? Let's go here. So I'm just going to show you how to use this and what that even means. So let's start. We have an angle A. I'm going to erase all this now. Erase. So I have an angle A of 49 degrees, and I'm going to use blue just because I like blue more. 49 degrees, and the side opposite from angle A is going to be a length of 24. I mean, you just so again, I just sketched it. Angle A, side length 24, side length 22. I could have put the B right here if I wanted to. It doesn't matter. It would have been the same. So this is a side, 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 angle. So this, the first part says, state the case, side, angle. And if you're thinking the other way, oh, angle, side, like for sure. Angle, side. It works, but obviously you could tell why the book didn't do that. Because all of you would chuckle as I'm chuckling. So this is 49 degrees. We've established for number 13 that this is an SSA. So I have a side, and an angle. Even if I drew this and made this over here, the only thing that matters is that to be in the right place is that an angle is opposite. So they would never call this angle A and then write, oh, this is side B. It's like, no, this is angle A, so then the side across from it is going to be side lowercase a. Okay, now then decide whether the measurements determine one triangle, two triangles, or no triangle. So let's look here. Oops, I don't want that. Yeah. So angle A is obtuse. Is 49 degrees obtuse? No. So we can ignore this for this problem. And if it's not obtuse, it must be acute. So we have some where we have values of h, which is calculated with h equals b times sine A. So in this case, what would that look like? H equals length of b, so 22, times sine of angle 49. It just says it right there. So yeah. So I set it up just to show you what it would look like here, but we don't actually have to use it, or we might not have to use it because we can look at this part first. Easiest part. If the angle A is acute, which it is because 49, and A is greater than or equal to B, the other side, so 24 is equal to or greater than 22, well, it's greater than, so it falls under here, then there's only one triangle. So I can stop. I don't actually have to calculate this out at all. I don't have to type it into my calculator, but if I did, it would look like this: 22 sine 49 degrees, 22 times sine of 49 degrees, so 16.6, and that would be h, or the height. But I didn't need to know that. I could start here and be like, oh, 24 is equal to or greater than 22, then it's all good. There's only one triangle. So you'd stop right there and be like, okay, well, this is an SSA, and there's one triangle. That's number 13. Let's go to 14. 50, 38. 50, 38. So again, I'm just sketching this. Like did not think at all about 50 and 30. Like, oh, don't these look pretty even? Like, I put literally no thought into this. As in, it's not to scale. I'm just drawing a triangle just to draw a triangle. I easily could have gone like this and been like, oh, well, I know the angle is supposed to be 50 and 30, but I'm just sketching it. So we have angle A is 50 degrees. We're just drawing what they gave us. Angle B is 30 degrees. And then side B is 8. So across from angle B. Across from angle B is side B, which is 8. Again, I have literally not done any calculation except to be like, oh, this is what they gave me. Now I'm just going to draw it out. First, state the case: AAS, ASA, or SSA. Okay, so angle, angle. Do we know this side? No. But let's go counterclockwise. Angle, angle, side. Oh, would you look at that? It's an angle, angle, side. And actually, if I do angle, if I do go clockwise, angle, angle, then the next bit of information I know is the side. And the reason I stopped there is because I'm pretty positive most of you are expecting a side there if AAS were to apply. So yeah, there it is. And according to the textbook, we can just say, oh, well, it's not one of these SSAs, so I don't even have to worry about any of this, and just be like, oh, AAS. One triangle. Yeah, that's 14. Let's see. Let's do 17. So we have one angle, and I have a side and a side, but I don't know where, where that looks like without drawing it out. So I'm going to draw it out. So I'll say angle C is 120. 120. So see, this is not obtuse at all. Like, oh, okay. I'm just drawing it, just have a drawing. Across from C, angle C is side C, which is 11. And I have B, which is 12. I could put the 12 here, or I could put the 12 there. It doesn't matter. Yeah, put it down there earlier. I guess I'll switch it up. Which means this is side B, which makes this angle B. Then this is angle A. Well, that's just all extra information that we don't even need to solve it. So let's look at what we got. I have an angle, a side, and then another side, which is the same thing as a side, and then an angle. So this applies, and let's look. The angle A is obtuse. Okay, when it says angle A, it's not referring to angle A like, oh, if this is B, then B is right here, and angle A is right here. No, it's just saying, oh, whatever angle that you're given, right? And in this case, we're given C. So we're gonna look at C and be like, okay, well, 120 degrees is obtuse. Okay, so it's one of these. It's one of these. And then I basically just have to determine, okay, is A, which is in this case side A, is across from the known angle. So the known angle is 120, which means that this is a side right across from it, just as in this is across from that, and this is across from that. Then if A, or the side across from the given angle, is less than or equal to B, which is the other side, so if 11 is less than or equal to 12, which 11 is less than 12, then there's no triangle. So for number 17, I could say, okay, this is an SSA and there's no triangle because A is obtuse, the degree or the angle given is obtuse, and the side across from the angle is less than the other side that they just gave us to work with. So again, one more time, 17 is SSA and no triangles. As a reminder, the only time you have to worry about this is if you have an SSA. If you have an AAS or an ASA, which means an angle side angle, which would look like angle side angle. If they gave you this angle, this side, and this angle, or any three, or this angle, then that side, then that angle, or that angle, then this side, then that angle, whatever. It doesn't matter what order or even direction you go to. It could be this angle, this side, and that angle. Then that results in a one triangle. So again, for most of these, you can do as I do and just kind of draw anything and just be like, okay, well, first identify how much information they're giving you, whether that's an AAS, ASA, or SSA, and then if it's an SSA, if it's either one of these, you just stop and be like, oh, it's just one triangle. I know it's going to be one triangle because the book said so. I showed from up there. But then if it's an SSA, then you have to go into your, oh, okay, well, the side that's known is across from the angle. Like, what's the relationship? Is the angle obtuse? Is it acute? And then if it is acute, then what's the relationship? And then if you need to do this, then you do. And then, if you don't, then you don't. And that's it. So let me know if you have any questions.